So here we have a range and maximum height problem for projectile motion. We're told that we have an object that's projected at an angle alpha to the horizontal, and the horizontal is projected at an angle of theta. And we're asked to find an expression, or to show that an expression for the range, which would be somewhere over here, and that distance there, we're asked to show that that is equal to, or is equal to, and just try to write it small enough, u squared over g cos theta sine 2 alpha minus theta minus sine of theta, and that's all in brackets there. So the solution is quite complicated, so it actually works out to be it's tricky enough to do. So first off, you look for Vx, Vy, Sx and Sy. Now we did this already, so I'm just going to write in what those values are. U cos of alpha minus theta minus g sine of theta t. This is u sine of alpha minus theta minus g cos of theta t, and this one is u cos of alpha minus theta t minus a half g sine theta t squared, and this one is just similar enough. T squared. And cos. Okay, that's it there. So we have to find S of x when S of y is equal to 0. Does that make sense so far? Right. Now, so what we want to do is, first off, S of y is equal to 0 up there, because it's 0 here and it goes up and back down to 0 in the y coordinates. This is our new reference frame, that's our x, that's our y coordinate there. So when S of y is equal to 0, we get 0 is equal to u sine alpha minus theta t minus g, that should be a half g, cos theta t squared. S is equal to ut plus a half at squared, that's where that comes from. So, when that's equal to 0, we can factorise out the t, which is the only variable in the equation. We get sine alpha minus theta minus a half g cos theta t. So the two solutions are when time is equal to 0, that makes sense because at 0 it's at y is the y coordinate to be 0, and when this expression here is equal to 0 as well. So we'll solve for t for this, and we get u sine alpha minus theta minus a half g cos theta t is equal to 0. Just get the half g cos theta t over to that side of this, be positive, but I'll just write it like this. Cos theta t is equal to u sine alpha minus theta. Multiply both sides by 2 to get rid of the half, 2 there, and then divide both sides by g cos theta, and just to rewrite that, we'd end up with t is equal to 2u sine alpha minus theta over g cos theta. So that's the time it takes for it to hit its range. Now to get to the range, we have to sub this into the value for x. Now I'm going to just box this off here and continue on over here now. So from S of x, we have it's equal to u cos alpha minus theta. I'm just going to put in t in red just so that we can see where that's coming from. 2u sine alpha minus theta over g cos theta. minus 1/2 g sine theta, and then it's t squared. So we have to be sure to square absolutely everything in t. So that's going to be 2 squared is 4, u squared, sine squared alpha minus theta. I'll carry on because it's still recording. I know the display has stopped responding, I'm not sure why. But I'll keep going with it. And then that's over g squared cos squared theta.